this software and elaborate a crack for it to circumvent some license checks or to use a game in a way that was not intended, for example, by cheating. When an attack is available, eventually, the attack can be shared by many different users so that all the clients that has installed the same piece of software could be compromised. This scenario is known as crack once, run everywhere, because the crack can be shared. So in this paper, we propose an approach called a diversified update. So basically, the intuition is that if a version of a program, the protected program, is cracked, the idea is to limit the exploitation of the crack by replacing this application, this program, with a program that is different. Because if the program is different enough, the crack should not apply correctly to the diversified program. Of course, to work, the diversification should work automatically, because we don't want to ask developers to spend valuable time in order to generate a new, different version of the program. So the generation should be automatic and cheap. Moreover, we should have enough diversified version to support the whole life cycle, the whole let's say, life of this program. If the program should last 1 year, we should schedule enough updates so that the crack can live a lot of time. So we propose this approach overview, which is, let's say, composed of some steps. I will give some details of each step. Basically, the key idea is to provide a program transformation to have many different versions, potential versions for updates. And then we use program clustering to identify what are the most different versions to deploy in production. The cornerstone of this approach is the notion of similarity. Basically, we define this similarity reusing the concept of non-compression distance, which is basically a way to compute the distance between two programs based on a compression algorithm. So basically, to achieve, to compute this metric, we compare the size of the two programs compressed each one by its own with the size of the compression of the concatenation. Why? The intuition is that if there are common subsequence of bytes between programs, the algorithm will replace these common subsequences with a placeholder. The more common piece of code among the two programs, the smaller the size of the compression. The first step is program transformation. To achieve our objective, we resort to an available tool that applies program transformation that includes many transformations. In particular, we use an obfuscation tool. Obfuscation was initially conceived as a program transformation approach with the main objective of transforming a program into an equivalent program that is more complex to understand because the control flow and the data flow is more tangled. So the initial intention was to generate a program that is much more difficult to understand and adapt. However, we use program obfuscation just to generate a new version of the program that is different from the previous one. And we resort to the second requirement of obfuscation that basically preserves semantics. So if you run the first program or the second program on the same input, you should obtain the same result. In particular, we adopt Zelig Class Master, which is a commercial tool for code obfuscation. It contains many algorithms implemented within it that we use as catalog of program transformation. We can use each transformation by its own, so that we have a list of potential versions, or also we can compose all the transformations together in all the possible combinations in order to maximize the candidate versions that we have for replacement. However, if the, let's say, atomic transformations available in the tool are m, basically the potential combinations of all the transformations are quite many. In our case, they are more than 100,000. If you consider this number and you have to compute all the pairwise similarity among all the versions, basically we have 6 billion similarity pairs to consider. It is a huge number. This number is very big, probably too big, but most important is unnecessarily big, because some obfuscations might be very similar. We don't know at the moment. So we have to undergo a filtering step to remove those atomic transformations that are not effective in achieving a high degrees of distance between problems. So basically, we need to filter those that are not effective so that the problem size is more manageable. And we use this algorithm to filter obfuscations that basically we called twin atomic obfuscation. So two transformations are called twin when they are intuitively very similar. Let's see how we do that. So basically, we compute, we take a program, we obfuscate the program with all the atomic transformations. So at the moment, we don't combine transformations. And we have a set of versions. We compare pairwise all the set of versions such that, and we fill this metric. So the distance between the program transformed with transformation 2 and the program transformed with transformation 3 is, for example, 0.7, so it will be stored in this particular position. When we have this matrix for all the atomic transformations, we can compute the distance among transformations in this way. So basically, in this case, we consider obfuscation, the transformation 2 and transformation 3, and we ask what is the, let's say, the distance between these two transformations. To do that, basically, we compare these two lines by computing that is basically the difference between the sum of the squared sum of the difference between how each of these two obfuscation behaves according to all the others. Basically, we call this value the twin value for obfuscation 2 and 3. We compute the twin values for all the pairs of obfuscations. We sort them so that we can exclude those obfuscations that are too similar. By excluding, basically, those obfuscations that have highest value, the highest twin values. More details of this algorithm are in the paper. I just wanted to give you the intuition during my presentation here. So we filter those obfuscations that are too much similar, and we keep just one of them. At this stage, we can combine all the remaining obfuscations in all the possible combinations to achieve a very large number of potential versions for updates. Okay, and we keep only those that pass filtering, of course. Among them, we compare at this stage the pairwise similarity. So we fill another matrix that is much bigger with the similarity among all the pairs. Eventually, we compute clustering. So we cluster together those versions that are most similar in this way. Basically, compute for each cluster the intrasimilarity as the average similarity among all the pairs of clustering of versions in the same cluster. We compute the intersimilarity as the average similarity among pairs whose element belongs to different clusters. In this case between cluster I and cluster J. And eventually we compute the similarity quality for the complete clustering configuration as the average intrasimilarity minus the average intersimilarity. Why we do that? Because eventually we want to maximize this similarity quality, which means maximizing intersimilarity and minimizing intersimilarity. So basically, we merge the two objectives into a single one. The configuration of versions was in which each cluster will contain elements that are very similar to each other, so that we can select the final configuration for update in this way. So basically, we pick one random element for from each cluster. Make sure that we don't select very similar elements for update. Okay, so this is the approach in general, and we gave some empirical evaluation of this approach. We took for this empirical validation 10 apps, 10 smartphone apps from the Android store, from the official Google store, let's say. And we use the Zelix Clustermaster as catalog of atomic transformations. We use a similarity based on the non-normalized compression distance, and we use RZIP as a compression algorithm in particular. So we define these experimental settings, and we will ask and answer some research questions. So the research question number 0 is a sanity check of our similarity measure. In particular, we adopt the same validation approach available in literature that basically is based on the validation of the idempotency property. So if we ask for the distance between one element to itself, the distance should be close to 0. To do that, basically, we take a large file and we chop it so that we compare the distance between x and x with an increasing size of x from 0 to 1 gigabyte. And we plot the results in this graph. So as you can see, the distance is very close to 0 until we reach a given threshold value. After this threshold value, basically the distance starts to diverge and give unreliable results. This is due to the way the compression algorithm works. In fact, when the file is too large, the compression algorithm basically chops the file and computes the compression for each segment separately. In this way, basically, common subsequences that are repeated along the file cannot be captured. So, as a first answer to this validation, to this sanity check question, basically, we can say that our measure is reliable until the file is of size 448 megabytes. If the file size goes beyond this limit, basically the results are unreliable. The second research question is on the distribution of similarity. So we took one of the 10 case studies. In particular, we took Skype, and we considered the similarity values for those obfuscations that pass filtering. We combine them in all the possible configuration and we reach 130,000 similarity values. We plot them in this way, and we see they are kind of clustered according to two different populations. One is centered near 0.3, and the other is centered more or less around 0.8. So they are quite spread in the possible spectrum, that is 0.1. However, we can see that the lowest similarity values are in this area that probably are going to be selected by our algorithm. Then we investigated how basically filtering works in selecting these atomic transformations. First of all, we note that all the case studies that we considered are between 100 kilobytes and 10 megabytes, so they are in the interval of validity of our metric, so the experiment is sound. And here we consider the 16 atomic transformations still without combination. We apply filtering and we see which obfuscation pass filtering. And basically, this is the result. On the lines, you have the 10 distinct case studies, and on the column, you have the obfuscations. A tick mark basically specifies when a particular obfuscation is used in the particular case study. As you can see, here I have the total number of obfuscations. Some obfuscations are used in all the cases. Some of them are used in many cases, 9 cases, 7 cases, so on. Some of them are used rarely. However, there is no common pattern on the obfuscation used. It looks like the obfuscation is subjective. It depends on the case study that we are going to consider. So, as an observation, is this one. Since there is no common recurring pattern on the atomic transformation to use, if for each application that we in the future want to protect in this way, we have to repeat filtering. Eventually, we applied the complete approach, and we evaluated how many diversified versions we can deploy. We use, in particular, we compare three search algorithms. The first is a greedy agglomerative clustering. We start from a configuration in which each element is assigned a distinct cluster, and at each step we merge those two clusters with the highest intersimilarity until we reach the final configuration where there is just a single cluster with all the elements. We use hill climbing. Basically, we start from a random configuration and we probe the neighborhood. In our case, the neighborhood is our configuration of clustering, from which we change an element from one cluster to another one. The last search algorithm is a single objective steady state algorithm. The configuration parameter is this slide, but I'm not going to spend time describing them. I just wanted to comment on the one-point crossover operator that we use. So basically, if we have two clustering configurations that are the two parents selected to create the offspring, basically we take a random number of clusters from the first parent, a random number of clusters from the second parent, and we have the first offspring. The second offspring is created taking the remaining clusters from the first parent and the remaining clusters from the second parent. Of course, these two clustering configurations might be not valid. In case there are duplicated elements, basically we remove one of them randomly. If there are missing elements, we assign them to a random, possibly a brand new single. We use the similarity quality as a fitness function, and we run it, and this is basically the result that we obtain. For each case study, I showed here the results. The similarity quality that we can obtain together with the number of clusters that the algorithm gives as a result. The number of clusters is important because it determines how many versions we have for update. As you can see, the greedy algorithm gives the highest similarity quality in 6 cases out of 10. However, in none of the cases, the number of clusters is the highest. If we move to hill climbing, we can see that in 4 cases, the similarity quality is the highest, but still the number of clusters is not low. Is interesting because even if the similarity quality is never the highest, the number of clusters is always the highest that we can achieve. So after this initial experimentation, we basically elaborated some conclusions, some observations to derive some interesting direction on how to extend this work. So the first extension is to move from a single objective to a multi-objective optimization, because at the end we want to optimize main features, at least the diversity of the versions, but also the number of versions that we have. So this problem is intrinsic multi-objective. Moreover, we want to test with a different metric, because at the moment the distance that we consider is a black box. It's based on the compression. We use a metric that measures distance from the point of view of an attacker that has to trace the piece of code from the original program to the updated program, and to trace commonalities in order to port an attack from one version to another. Eventually, we want to run controlled experiments with human participants to measure the real effort required to port an attack from one version to another version, measure what is the learning that an attacker might benefit when moving from one version to another. So concluding my presentation, I present you this threat model of software hardening that basically wants to limit the exploitation of a crack by resorting to a frequent updates of the program with versions that are always in the list. This similar. I presented an overview of an approach that can be used to deliver automatically this result, and I gave an initial, let's say, experimental validation of this. Any comment and feedback is more than welcome. So if I understand correctly, the question is if this obfuscation transforms just the code or also the memory. You mean the runtime memory? At the moment, I think that in the catalog we have just transformations on the code because they are supposed to make the code, the static code, harder to analyze and reverse engineer. However, in literature, there are other approaches that are interested to block, let's say, the comprehension from a dynamic analysis point of view. These algorithms are not available in this tool that we used. However, we wanted to extend this approach by including also more advanced obfuscation.
How when you do this transformation, you generate multiple codes that have the same behavior. So for the same set of input, the same set of output. So how can this be improved?
So the question was if the semantics is preserved, if the input-output semantic is preserved, what is the improvement with respect to security? I think that for us it is a hard requirement. We don't want to change the semantics of the program. When we talk about the code hardening, we have to avoid any possible bug or fault or defect added by transformation. This is something we cannot do. The gain from the point of view of security is that the representation, even if the algorithm is the same, the representation of the algorithm is different, such that it's harder to be understood by a human, and it's harder to be understood by an automatic tool. Let's say that's this is the, let's say, the basic assumption of code obfuscation. This is the gain we have from the point of view of security.
How can you guarantee that the user?
Yes, so what we do, the question was how we can guarantee that have different versions of the problem. So at the moment, with the available, let's say, app stores, we cannot distribute different versions to different customers. Having different versions for different customers is what they call diversity in space. The approach we do the diversity in time. So everybody will have the same version, but they will get soon an update, and everybody will get the update. So that if a crack is available for an old version, the crack will be not working on a new version. So after we push an update, basically we destroy all the possible cracks. And there is a way to achieve this objective. Basically, I didn't mention in the presentation, but we can make every update mandatory by basically changing the network protocol used by the application. The application is not going to work because when it connects to the server, basically it doesn't work. So the updates are mandatory. And we cited the previous work by us, where we propose this way to make each update mandatory.
Now, when you talk about the clustering, if I correctly understood, you're trying to maximize the number of clusters and maximize the similarity within each cluster, right? This is the fitness function of your genetic algorithm?
At the moment, our fitness function is a single fitness function, is just the similarity quality.
And you allow, and when you create, your genetic algorithm is allowed to merge also clusters? Or it has to
yes.
always keep. So in this case, then if you are always maximizing the intra-similarity, then you'll end up with only like one huge cluster, correct?
Actually, we don't maximize the inter-similarity, we are maximizing
the intra.
The similarity quality, which is basically the difference between inter-similarity and inter-similarity. So if so we are maximizing inter-similarity and minimizing inter-similarity because we
yeah, but when you are actually maximizing the intra-similarity, you are automatically minimizing the inter-similarity too.
As far as I know, they are two contrasting goals. Because if you have, let's say,
if you want to maximize the intra-similarity, your best case is to have all the elements within one cluster. The intra-similarity, it means minimize the intra-similarity. That would also have them all within the same cluster, right? Because then you wouldn't have any inter-similarity at all. There will be zero. There will be going. I think
because if you have elements in the same cluster that are very different, the intra-similarity will drop.
Oh yes, yes, yes.
It's very technical.
Yes, yeah, I see. Yeah, yeah. Yes. Yes, yes. Thank you, thank you.
So as a result of this algorithm, basically you run our approach and you have already the set of applications that you want to deploy. So you prepare them offline and then you schedule for publish. So you don't need to run this algorithm each time you want to publish it. You run in advance and you have the versions ready for update. When the developers push a new version because new features are released, then you rerun this and you have a of versions for update for the newer version of the Now, the testing is not done on the testing is done on the original program. When the program is ready to be deployed, we apply this.
Our second part is a multi-objective approach to prioritize and use non-bugs in open source development. Ultimately, algorithm and the recovery present.
Hi everyone again. The author of this paper is Simon Drayton with the help of Alpha Alex, and Jefferson School. The name of the paper is a multi-objective approach to prioritize and recommended bugs in open source repository. This is the agenda of the presentation: introduction, proposed approach, problem formulation, empirical study, results and analysis, and conclusion and future goals. So, systems inevitably have to change to remain useful. Business rules can change, bugs can find. So the system must evolve to meet changes user needs. So according to the Lemon's law of a software evolution, the system tends to be more complex the measure that it grows. So how to determine which order these bugs will be addressed? Count of the views of the various user profiles involved. And how is the bug prioritization is done today? Usually, large open source software has a repository, an open repository for the community focused bugs. And the process of choose which bugs will be developed is human oriented. So the people or the community choice which bug will develop. So this is a personal, it's usually a personal criteria. So the problem is because the choice can be concentrated in interesting parts of the community. And I think a part of the program cannot be achieved. And how to take this problem? Firstly, to stimulate the developer to be focused over time from marketing goals regarding the system. And to reduce the developer waiting time using implemented examining large of this report. So a proposal of this paper is a framework limit. They are bugs, and the approach is composed by three stages. The first one is a bug prioritization process. In the second stage is recommend to develop the most suitable solution among these ones in Pareto form. This is an overview from the framework. We have 5 steps in 2 stages. The first step is the community or the contributor reporting the bug. And then the create will do in the time of the contributor report the bug, it needs to be the severity of the bug, or how severity is the bug, or how from the system. Then express in the system or the curator the importance of the bug comparing with the other bugs that exist in the April product, and says to the technical requirements, for example. The third stage is the community saying his opinion for the bug, both for how important the community is the bug. The fourth stage is a multi-object optimization to prioritize this bug. This stage is the recommendation stage. So, as a multi-objective approach, we have big number of solutions within the research space. You need to know how the solution is better for each developer in the front end, Pareto front. Reviews of how the data is input, so the contributor input the severity, the expert priority, and technical precedence. Relevance, the niche objective use the experience lab that's provided to the expert tool to determine how solution is better for each developer. Formulation. In the by prioritization stage, we consider a set of bugs available to prioritize. B is a set of the bugs that was prioritized. The model proposed is maximize the importance, minimize the risk, subject to the precedent, to technical precedent. The function importance take care about the priority and relevance on the bugs. So we want to maximize the priority and relevance for bugs. Some risks encourage to early resolution of bugs that is specified for more severity by the community. So it's considered the opinion of the community about the bug. In recommendation stage, we have a set of the areas of the system available to the bugs are concentrated. The set of developers that have to develop this bug, and the experience of the developers. And then we have the compatibility that informs how similar a developer experience is for each bug, or the level required for the development bug. The integrated study was made with was divided into two phases. The first one was a artificial experiment with the developers and the bugs are developers was artificial, but the instance was a real world and one instance artificial, and the other was used with real people, but the instance was artificial. The real instance was extracted by the page editor from repository. It was collected on February 19, 2016, with 508 developers, and the experience level instance was artificially generated. The artificial instance was designed to represent a hypothetical bug repository of a scholarly management system. It has 100 bugs artificially generated and 3 outs that the bug can be loaded. The values of severity have relevance, priority, and experience level. This was randomly generated. The matrices and parameters that was used, the first one was an FA2, Morcell, and idea, and a random algorithm. The resolution analysis. Some important things, because of the natural stochastics of the evolutionary algorithms, each algorithm was executed 30 times, and also conducted a linear correlation to determine if the two objectives was conflicting. So the values imply that they vary in some positive correlation, so we can conclude that the two objectives is conflicting. The research questions, it's about the difference of or how this was good for the approach, and in hypervolume and general distance, and the real world, in both an artificial and the real world distance, the NSA2 has better results. In Morcell and the London search has better results in the spread. Here's a statistical analysis from the results, and we can see that Morcell was better in spread, and SBSE2 was better in hypervolume and in general distance. IDEA has good results in hypervolume and in spread. Here's a sanity check. In the left side, we can see from hypervolume. In the right side, general distance. In top, from the artificial distance. In down the importance of to the real world. And as you can see, the London search is really far from the Pareto strong. So it's from sanity check. The second research question is to say if the results of PR bugs is competitive with the human, with the human choice. And the results we get that the importance was maximized, so the PR bugs have proposed a set of bugs with more importance and lower risk. So the approach is really good for the prioritization. Some trace causality. some internal traits is the value of the experience from the developers in real world instance was defined influentially. So the parametric search techniques was defined by us, but we know that if we change, the results can be different, better or not. And some external traits is we decide to achieve more generalized results using, for example, a bigger search space or a bigger repository, more and more developers. We can do this. Some conclusions and future works. An automated approach called PR bugs. We propose it to prioritize and recommend bugs in open source repositories. Was two experiments was performance. NSG2 was performance builder techniques in hypervaluing. Mosel was superior in terms of the spread. And NSGI2 in there was equally good in generation of distance. And the proposal can be said to be human competitive. As future works, we intend to include the concepts of robust optimizations to deal with uncertainties of the values that the user inputs, and develop a strategy to automatically predict of which area a bug belongs, considering the textual similarity to other bugs previously reported.
I may have missed this, but when you did the case study, how did you get data for risk and technical precedence?
The risk and technical precedence we use in real world instance, the case repository provides this information. But in artificial was
generated. It provides risk. So it provides risk information.
No, it provides the severity. So with the severity, we can say the risk.
Okay, right. So I missed that slide.
Yeah. Because the risk is the objective is used for importance we use priority and relevance, and from risk severity. So the things is provided by the case in real world. Yeah, priority relevance.
And the relevance is also provided by the report.
Yeah, by the report.
What was the state of the art in this area? Have people done this before with search-based techniques?
Yeah, this paper is evolution of a paper that was presented last year. Was that this paper was the first in this area? So,
so
this one is the second. It's not the third because the one presented yesterday had the same problem.
So final point is, could you mine the repository in order to extract developer experience information? Because you need to actually, you said in the case you randomly generated it, could you derive that information from the repo, from things like the document?
Yeah, we try to do this using the scene which developer, the bugs that the developer previously worked. So we know how, more or less, where he preferred to work and which bug kind of bug is preferred.
You didn't use that in this case?
No.
Thank you.
Our subtopic is testing generation efficiency predictive models of the FSM based on the MVPP. The speaker is William.
FSM is extended finite state machine, and it is one of the most popular form of classification. It can be represented and fixed level. This figure is simplified FSM, and this is a transition task generated from FSM. Model-based testing has been intensively and extensively studied in the past decade, and FSM is a widely used model of software testing in both academia and industry. At present, most software testing researches on FSM have focused on automatic test status generation and test data generation. An important issue of test generation efficiency has not sufficiently addressed. There are many generation techniques on FSM. It includes random, symbolic execution, genetic algorithm, and so on. And the testing efficiency directly related to whether this generation technique can be applied to the real industry program. So in order to study test generation efficiency on FSM, firstly, we should make these two questions clear. The first one is what factors affect testing efficiency on FSM. And the second one is what relation exists between them. For the first question, the previous work in our lab has conducted an empirical study on 8 FSM models and identified the key factors affecting the efficiency. The study has demonstrated that some growth factors have strong correlation among each other. With a multiple linearity exists. And this table is the influence factors. And then the length it includes length of path, number of variables, and the number of variables defined in the event, and so on. For example, then the length of path increases. The testing efficiency increases. For the second question, what relation exists between them? The mapping relation can be known by the predictive model. Now in this paper, we consider the influence factors and the independent variables and the testing efficiency and the dependent variables. And we try to find the mapping relation between them. The preliminary work in our lab, we used the multilinear regression predictive model and the two-stage neural network predictive model respectively to conduct the predictive model. It demonstrates that there is a linear relation between them. Because there exists multiple linearity among them. We have used the principal component analysis independent variables to conduct the predictive model. So this method can avoid the convergence, but we need to inaccuracy of the predictive model. We try to explore another method to construct a predictive model. Some researchers compared the performance of regression analysis of deep neural network and multi-gene genetic programs in heavily multiple linearity problems. We found that MCDP regression can be more accurate and efficient than others for modeling nonlinear problems. So in this paper, we propose a new approach based on MCDP to predict the test generation efficiency on EFSM. Then I will introduce the multi-gene genetic programming. This programming extends standard with parameter estimation of classical regression, which is able to render two information patterns within the multi-dimensional information domain in high efficiency. GP is a machine learning method that involves computer programs to perform a task. And this figure is an example of the GP model. And the representation of the GP model is as this figure. And it represents a potential solution by tree structure. Its main advantage is it can generate the mathematical expressions without any clear form of existing relationships. The leaf node is the terminal set includes input variables and constants, and the function set is included by the mathematical expression. MGPT is a robust variant of GP which effectively combines the model structure selection ability of the standard GP with the parameter estimation cover of the mathematical regression. And this figure is a typical simulation of the MGPT model with this parameter. This is the process of MGPT algorithm. In the part 2, I will introduce the detailed implementation of our approach. When applying MGPT in constructing predictive model, firstly, we should set up some parameters in MGPT and then analyze the process of applying MGPT to predict test generation based on EFSM. The terminal set includes factors on EFSM and constants, and the primary two functions include and, plus, multi, and so. The fitness matter in our research, we defined it mean square error. The parameter for controlling the run is determined by time and error. The criterion for terminating a run is the maximum number of variations, or the threshold error of the model in the evolutionary process. This algorithm is MGPT algorithm for test generation efficiency predictive model. The input of this algorithm is the influence factors and the efficiency metrics, and the output is a predictive model of test generation efficiency. We set up parameters in MGPT, and then initialize the population and infer the depth of gene T is less than max T, and number of genes is less than max T. And then evaluate the performance of the population then cross-check termination criteria. The third type is the experiment. Firstly, experiment design. This is the whole process of our experiment. First, we collect data and then divide it into training and the testing subset, and we use MGPT to analyze dataset and verify performance. Verify the model's performance on test dataset, and then was calculate the performance errors. In the experiment design stage, we will introduce data processing and performance evaluation criteria. For each subject, the test cases were generated by geometric algorithm for potential complete feasible transition paths with different lengths. A large amount of activities, practice information, and test generation costs were recorded. This table is the EFSM we use in our experiment. After collecting the data, then we divided it into training and testing subsets. Cornerstone algorithm can pick out the progress subset in the whole data set. The subset data can be evenly distributed in the whole data space. For example, this figure is the ATM model's data distribution divided by cornerstone algorithm. Then the evaluation criterion of MGDP models is designed and square linear correlation coefficient between test generation costs on EFSM and the model output. To motivate our experiment, we designed 3 research questions. The first one is whether the proposed predictive model based on MGDP algorithm perform effectively to forecast the pattern with test generation indices on EFSM. The second one is do the influence factors excluded by PCA have an effect on the effectiveness of the MGDP predictive model. The third one is that the MGDP model outperforms GP and DP model in the predictive ability. To answer research question 1, we have done 8. We conduct 8 MGDP-based predictive models on 8 different EFSMs, and the result is this figure. The line in this triangle is the actual test generation, and the line in this circle is the predicted value, the predictive model output. The closer the 2 lines, the better. So we can see from the result, the MGDP-based predictive model can effectively forecast estimation and efficiency. To answer the question 2, we adopt PCA to analyze the relation. The key influence factors of each EFSM is and this table. And the comparison result of MGDP with PCA MGDP. We can see from this table, the MGDP model are better than the PCA MGDP predictive model. To answer research question 3, we compare the different predictive models. Include predictive models and DP predictive. And we can see MGDP predictive model is more accurate than that. In the textbook. In this table, we are the first to propose a new approach based on MGDP. And the empirical study demonstrates it is effective to focus pressure data generation and you can extract with the PK and GDP model. The result shows that GDP and constrain the data dependency among different functions. Besides, compared with the standard GDP model and GDP network model, ability, the performance of unpredictable model is best.
You have to completely understand together.
So, do you think this will generalize to models that are unlike the ones that we use to train?
I think
The orientation. Did you test that on a test set separate from the training set? Use a separate evaluation?
The effectiveness of this model is related to the data, to the data release. So if you give me the enough data and MGDP is MGDP can be effective.
Based on your experience. Generalize things.
Yeah, that's why is tend to demonstrate machine. And the test is finished. And maybe it can work out this one and then calculation.
What kind of constraints that can be included? What kind of constraints? You said there are constraints.
This is a simplified Yakazan, and the real Yakazan includes the condition and event and action, and the condition.
So if I'm a practitioner in the industry, I want to use this, what kind of scenarios am I likely to mention? So is it a case that I want to know how hard the model is, or how much compute time, or how long you want to wait? What is the main reason for using it? I can check your thing.
You can gather the industry. Then choosing generation technique. We can use this to forecast it and whether this technique can be used using yes, it can offer this information whether it is to generate a possibility.
The last part is search-based generalization to the common code.
Hi, so, hello everyone, my name is Kim, and in this presentation I'd like to talk about a search-based approach to generalize and refine source code templates. First, a little bit of context. So this work takes place in the context of program searches and program transformation. And they're useful for all sorts of things. For example, if you have several instances of a similar bug, you'd like to have a concise way to find all of these instances of the same bug. Maybe you'd even like to make a transformation to immediately fix the bug as well. Is to build custom refactorings. Maybe the refactorings of, for example, if it's aren't enough, and you like to, for example, change different API changes, and you like to easily express those with transformation. And the specific type of searches and transformations that we're looking at, they're specified in terms of code templates. There's a concrete snippet of code, but augmented with a couple of additional constructs. For example, you can put in wildcards or variables or add annotations to your snippet. Some examples in the slide report. So these code templates, they make the specification of the transformations, they make it easy to learn. But even then, writing program searches and transformations is still something that is hard to master. It's not always easy to make. You need like the right transformation that gives you exactly the right. And this is what our work is about. We'd like to assist the developer of these searches and these transformations with a search-based approach. Improvements to their transformations. Right. So the search and transformation tool that we're using is SSBSE. That's also a tool that we've developed at our university. And with it, we can search and transform Java projects. We can't just express we want to transform certain parts of the code, and we can't just say like we want to transform all the parts that look like this. But we can also, to a certain extent, we can specify that we want to transform that behave like this. So we can also express some semantic constraints in your language as well. Example, this is just a piece of code, and at the top you have the declaration of the field, and below it the getter of that field. So that's fine. What I don't like so much about this code is that I directly refer to my field in the rest of my class. Because I already have a getter, I'd rather have that I always use the getter method instead. So what I'd like to do now is express a template that will look for all direct field accesses, not just of the field administrator, but across my entire project. I'd like to look for all direct field accesses. And this is what the template looks like. Actually, there are two templates. From line 1 to 7, we just express a class with a field and its getter. And on line 10, you have the second template, and that just expresses a direct field reference. So yeah, as I said, the template basically is like a concrete snippet of code, but with a few additional constructs. So it can still kind of recognize like this is a field declaration, and this is the getter method. Yeah, and that's the field access. Now let's look at it in a bit more detail at this template. At line 1, I specify I want the public class both, and both is just the syntax for a wildcard, so match it with anything. Then on line 2, we have our field declaration. It says we want a private field
question mark field type, question mark field name. And these field type and field name, these are meta variables. Actually, they behave just like a wildcard. They match with anything. But this time, the matching value gets bound to a variable name. So we can refer to it later on. Then we have our getter. And what's interesting here is on line 5, it says that we return blah, blah, blah. So we can return anything. But actually, there's something attached to the blah, blah, blah. That's this. This is something called a directive. And with a directive, you can attach a constraint to a piece of code. So what I'm actually specifying is that I am returning anything that refers to field name. And we know what the value of field name is because we already established this value on line 2. So that's a directive. And there's also one on line 7. That's the match set directive, which just says that besides the field declaration and the getter name, it's okay to also have other class members. Nothing special. Right. So that's the template. And if you actually match the template, if you execute the template, then you get these results. It's just a list of all the value bindings for all the meta variables and also the classes that match with the template. So for example, we find that the class 2 button, well, I don't know if you can read on that. Maybe a bit small. So it just gives you a list of the matching results. Right. So that was a fairly simple example. This is a more complex example. I'm not going to explain this in detail again. It's just to say, like, given the same building blocks that I've just explained, the wildcards and the meta variables and the directives, or given the same building blocks, you can build fairly complex structures. And you can imagine that it's easy to make some mistakes here, or that it's tricky if you're not familiar with this tool yet to make a mistake, then you need to tweak a bit to get it right. And that's where we'd like to make use of a search-based approach. We'd like to assist the users of our tool in case the template doesn't provide exactly the desired results. Maybe it provides too many, maybe it provides too few matches. So our search-based approach is going to take a template that isn't perfect yet, maybe it's too much, it's few. It's going to take such an imperfect template and it's going to keep on mutating the template to achieve a better one that, well, the goal is to find a template that finds only the results that we're looking for. So again, the input to our approach is our imperfect template. And secondly, something we also have to specify is what matches are we actually looking for. So if you have your imperfect template, maybe you still need to mark in the current results, like, okay, this is actually a match that I don't want. So you have to specify this is actually something that I don't want. Or maybe this is the result that I missed. But in the end, you just specify a list of results that are desired. Okay. The evolutionary algorithm that we're using is pretty straightforward, so I'll go through it quickly. So we start with our imperfect initial template, and we copy it a bunch of times to make the initial population, so generating 0. We do turbulent selection, we select a couple of those, we do mutations, and we also exclude the mutants that have fitness 0 because they're not going to lead anywhere. Those mutants that we've already produced in previous generations. We combine the two back into the new population. We keep on repeating until we get a solution template that matches only with our list of desired matches. Okay, so let's take a closer look at the mutations themselves. Actually, we have a whole suite of different mutation operators. And there's two categories. There's atomic operators and there's composite operators. An atomic operator is only going to make a local change within your template. And a composite operator actually is built on top, is expressed in terms of these atomic operators to make multiple changes in your template. Just to give a few examples, you have the replace by meta variable operator. And what it does is just picks a random location within your template and replaces it with a randomly chosen meta variable. So this is a simple example. We have an initial template, system output like hello world, and we're going to apply the mutation to the hello world, and it will be replaced by the meta variable. And to give an example of a composite operator, the generalized type. Composite operator is what it's going to do is select a random occurrence of a type within your template, and it's going to abstract it away. Look at the bottom part. Every occurrence of in this case the expression type is replaced by a wildcard, but we still maintain the relation between all the occurrences of expression bit. We still maintain the knowledge that they all refer to the same type, but we just abstract away which type. So this is an example of composite operator. And then one more thing about add directive atomic operators. That's just not one mutation operator. It's actually a whole catalog of different mutations, because we also have various different directives that you can attach to a piece of code. So the reverse code is the one that I gave in the example. Right. So that was the mutation operators. Now onto the fitness function. It's just a single objective, but the fitness function contains two components, and the user can choose like how much weight do you give to each of the components. And the two components are just the standard F-score, and something new is the partial score. So with the F-score, we're just going to measure, given a template, how many of our desired matches did we find, how many undesired matches did we find, how many results did we miss. So that's expressed with the F-score. And this is a very coarse-grained measure, because it can take several mutations to a template in order to find an additional search result. So in that sense, it's very coarse-grained. If you look at the fitness graph, it goes like, yeah. So that's why we need a second component in our fitness function. That's the partial score, and this expresses that for each of the matches that you're looking for, you're going to compare that match to your template and see like how close are they to each other. Do they match completely, or does only like half of the template match with the results that I'm looking for? So this is a more fine-grained measure to push the search in the right direction. To give us an example. Private local host name, and let's say that it produces 2 matches right now. And if you look at the results, you see that private string message. That's one we're looking for. That one is desired. Private image drawing. Okay, we're also looking for that one. The private in font size, that's not desired. And the more interesting is the partial score. How does it work? First, we're going to look at each of the desired matches one by one. So first, we look at private string message. Does that match entirely with our template? Yes. So that gets a perfect score of 1. Then we look at the next desired result, which is private image drawing. That also matches perfectly. Also gives a 1. The public tool only kind of matches with our template. Because you see the private doesn't match with the public, which is
why it only gets a 2 out of 3, but still it's getting closer. And you just take the average of all of that and you get the partial score. And for a quick tool demo, let's see. So this is what my very simple template that I'd like to generalize. A method declaration of an accept visitor method. And there's also a second template attached to it, which is a call to that accept. And now I'd like to automatically generate a template that establishes the relation between the method declaration and the call to this accept visitor method. Okay. So we just start the recommendation editor, and I select which template I'd like to improve, which is the one I've just shown you. And then I have to specify which are actually the results that I'm looking for. Prepare that. So these are the results that I am looking for, and I just push the button and let the search-based approach do its thing. I don't know if any of this is readable. It's very small, right? Yeah, so it just found the solution. But this is a very small example. It only takes like half a minute, but more realistic examples can take already, I don't know, half an hour, something like that. So here you can see the fitness score evolve. You can also see the F1 and the partial score separately. You can also see which was the best template that you found so far. If you look at the right, you can see it changing. You also get a nice chart to see how the F1 score and the partial score evolve over the generation. Yeah, and that's the tool demo. Okay, so how did we evaluate our approach? Well, the main question to answer is how effective is our approach at finding exactly the results that you're looking for. And the experiment that we did is to generalize the instances of a design pattern. Why did we choose this particular case? Because a design pattern already makes for a pretty, if you want to generalize all the instances of the same design pattern in the template, involves most of the advanced features of our template language, because there are some constraints that you need to express our design patterns, like this is a subclass of this or this called that. So we make use of most of our toolset here. So that's why we chose it. So the experiment is to take one concrete instance of a design pattern, and it has to find all instances of the same pattern in the project. So you start as an input template with one concrete instance, and the desired matches, the list of desired matches are all instances of that design pattern. And we've done this experiment using a couple of Java projects where we knew in advance where the design patterns are. They are documented in source code. So we chose JHotDraw and the match web search engine. Just to give an example of what does a design pattern look like, well, a concrete design pattern looks like in a template. So it's just concrete code. There's a little bit of pre-processing that I've done here. Most of the irrelevant methods that don't really affect the design pattern at all. This is something that the average user of our tool could easily do, so we do it as well. Something we do as well is we attach protect directives to the code. So we've done it here. Maybe I should explain. Class about the first interface just declares the factoring method itself. The second class is an implementation of this factoring method, And the third class is actually the product that is being produced by the factory method. And I've attached a protect directive in a couple of places to the factory method itself, to the instantiation of the product. What this protect directive actually does is it prevents, it tells the search algorithm that you cannot abstract this part away, or you cannot remove this from your template, because if you do so, you're definitely going in the wrong direction. So that's what we've also done. Then we can take a look at what does a solution look like produced by the search-based approach. It looks sort of like this. So this is the factory method as a template. And you can see that it's connected the factory method interface, and a subtitle of that will be an implementation of that. So that's one possible option, but it might as well have said the factory method has to be overridden by that. So there are different options to express the meeting. Likewise, the second and the third class are related as well because they produce a product of the same type. This might be interesting to show as well. This is one run to produce a template for this factory method. And you can see here in red is how the F-score evolves over the generation. And you can clearly see like this is very coarse grained. And the partial score is much more fine grained, so it definitely helps you to put it in the right direction. Right. So back to the experiment. So the setup is we ran it with a maximum generation of 0.50. Our population size is rather low, it's just 30, just because the calculation of the fitness of the template is rather expensive, so we set it 30. The F-score got a weight of 0.6 and the partial score 0.4. We enabled most of our mutation operators, except for the ones that literally insert new code inside the template. This just isn't necessary because we're just trying to generalize a piece of code. We don't have to generate extra code, that's why we deal with them. And we perform 10 runs for each design pattern. So this is what the results look like. In the first match column, you see the number of desired results for desired matches for the template. The success column decides out of the 10 runs, how many times did you find a solution that matches with only the desired result. So you can see that in most cases, well, a significant amount of runs that did find a solution. There's only one design pattern, the first one, where we always didn't find it. Also interesting would be the best fitness column that just shows the average fitness that we average over all the runs, the best fitness that we could get. The takeaway here is that we in all cases we can definitely take the starting template and significantly improve it to get more of the desired matches. And then the last column, the JMPS, just looks at all the successful ones and says how many generations did you need to achieve the solution. So usually, well, the lowest one is 26 generations, and the highest one is 150. So it's okay. So to summarize, I've just presented to you a search-based approach to assist the users of the articulate tool to recommend improvements to their search templates.
future work is to not just look at the templates themselves, but move towards transformations, where you can say, I have a transformation for that works for one system, but I want to migrate it to, I don't know, a fork of the system. And a search-based approach could be used to migrate from one system to another. And finally, if you'd like to play around with our tool, you can find it on. And that's it. Thank you.
I believe your tool is already a transformation because you are doing the endogenous transformation. So you are, each time you are choosing one operation among others to move from one state to another, it can be also seen, your search-based formulation can be seen as a solution-wise. It can be a sequence of transformations operations that you can apply to go from one state to another state. I think that this formulation is not appropriate to this problem, maybe because it would take a lot of time to actually converge towards this. But my question was, how would you help the choice of your mutation, since you have an idea about what you want to go to? Is that used when you were saying, maybe I missed this, that was used to remove the irrelevant operations or the transformations?
In the end, it's still the user that has to know, like, these are the results that I want in the end.
No, but when you define what should be the result, right? So how would that helps the evolution to know what are the, if you want to look at it from a smarter way, if you want to, instead of choosing randomly, operations, can I know, like when I look at, for example, the result, would I be able to distinguish between the operations that may lead towards that result? Is that something that we can foresee ahead of time?
Yeah, that's actually something interesting. You can definitely help process if you know a little bit about all these directives and different things that you can put in a template. If you know that I'm looking for this kind of template, you can say, like, I don't want these mutation operators because we don't need them.
Yes.
So that's definitely.
That will be a gray box instead of a black box. Gray box, optimization. Okay. Okay.
I'll look on that. If you're going to take that kind of probably branching down, use branching down. Because effectively you start from your solutions that you're looking for, and then you try to generalize that, and then admittedly you don't know where to go. Exactly. So you can shift it somewhat, and then you can use branching down. So then you can say, well, how far am I going to go down this path after this looks like I've gone, and it's very that would probably be a lot more efficient.
Sorry? No, because only the F1 looks at the results that you don't desire. If you only take the partial score and let it do its thing, eventually it's just going to lead to just a wildcard. It matches with everything. And that's why we need both.
So there's two things.
It's just one fitness function, but you attach a weight to both components and you just have them. Yeah.
Are you familiar with the work by Alberto Bartoli? Essentially using GPU to search for regular expressions.
Yeah.
Kind of similar.
Yeah, that's definitely related. Yeah.
That was entered for, I think, probably a decade this year.
In the end, it's all abstraction with a couple of declarations too. Yeah. Yeah. Yeah, I mean, that's definitely something interesting to look into, but to be honest, the reason we're not really interested in the generalization of design patterns or something like that, purely test our approach. Yeah.
Now Justina Spectra will announce the details about the next SSBSE edition. And support her.
Very happy. Very happy.
I don't know.
Yeah, so Lars is meant to be here. He was actually. Lars, you have done this. General chair for next year was actually here. He was at the steering committee by a Skype call. And then he said, okay, well, given the way here, he doesn't give you the rest of it. Right.
So before we talk about what we have planned for next year, I'm going to give thanks to the next year, the symposium will be held in California, in Germany, right after FSC, the 9th and 11th September. So you have our website. So this is the organization fee. So first of all, I thank you for your company for doing as the teachers and Renata and I would like to also thank the team members who are here to help us with the organization and thank you for the Polygon is in the middle of Germany and we cover and its population is just under 1,000 people, and the number of sites, including the entire part of the lake, from the century and the conference will be happening at the university. In particular, in times here. And the FSC conference will be held in the country of Union Fund, which is actually the world's largest computer union. So I'm going to you can fly directly to Pentagon airport, but also at the other larger international airports like anywhere in Amsterdam, so anything that you take to Pentagon. First of the website, the services for us and the hotel, so we find the travel. The weather should be really nice, about 20 degrees Celsius, about 68 Fahrenheit. Therefore, people are doing work on the outside. The German budget America. Don't you see it? Now we're talking about scientific program. We have two great fields, one from Morocco and from University of Birmingham, and one from another person from University from Birmingham. Certain aspects are actually already reflected. Now, a few new things for SSBSE. So we want to involve you a bit more in the tutorial. So we put up the call for the tutorial, and we particularly looking for the proposals that involve theory. Next, we invited some sessions where we invite authors of papers, other conferences, or authors of papers in journals that are very relevant to this. And we really like to see for great things going on, and we have also other benches that really want to give us to our people. Finally, we implemented the restriction on the graduate student class, so we have placed under the great work in SSBSE.
That's that maybe we can't fund them to come. We have folks who are doing really great work that we might not see in the conference. And if they're going to be mentioned at SBSE or larger events, so a nomination to a suggestion to transfer papers to W. We have the usual best paper award for best challenge track paper, and I really will be offering my two other prizes yesterday. Recall the biggest buzz award, the most boldest statement, and also the biggest banana award, the biggest stage, and I noticed that five different awards, I noticed that three different policy, but I will certainly be judging those.
Here's our program committee. We're going to be reading all the papers, and we have to thank all of you who can actually contribute to the conference and reviewing papers, and we'll see some of the we have
And the thing I want to make is that it turns out that our LOXCS number is got to be quite good. 10666. Okay. So next year, this book will be called
and the best paper to be invited to the December 27th special section in the International Symposium. It's time to event. And we will plan actually we have coordinate that. So you can try, and we will submit it. Finally, we are looking for content. This is going to be recommended and should recommend you can if you want to contribute to this symposium, please send directly us. And then if you have any suggestions to like the sponsor, and we have different sponsor packages below on the website.
But for one set of really high values, it's very remarkable. coaches will see the same. Have one personal connection with everything. Personal connection with everything. So if you really have a personal contact in the company, really the best thing to do is grab this material and then use it. Or you best use it. Personal contact with them. Don't think people and keep asking money about using it. Okay? But one said is really high bar, tends to use that again. And that balance that sounds like really good.
The deadline for work on today. The deadline for abstract March 5th. Friday. And review and next class. Next week. You will doing this resolution. That is not based on numbers. Yeah, put the explanation which can find the accepted. The total of the research technical section is depending on the days. 3 exceptional events. 72 attendees. And 7 inches of rainfall in 24 hours, which means not none of all the people will you know that you have live stream of all your posts and they are all available on Facebook. If you make know that all the posts that is 4,000 people just in 2 days, and yet more than 1,700 people working all your contribution it's not just in the rally, but it's all over the world already. The most used work has been the one that we are using yesterday. The third thing, the second one, is I won't really have and third was the opening. Full one, however, is prepared for next year. So, but because really, really so quickly, the central effects about EPM, then you see that this is from longer. I expect that next year we will finally have one of all the things that we like to do, the current members, all our sponsors,